Hi guys, welcome back. This is Kaushik here, and today I came up with another video on data structure and algorithm. And today we are going to implement stack data structure using Java programming language. So let's see what stack data structure is. A stack is an abstract data type or collection wherein push denotes the addition of data element to the collection and pop the removal of data element from the collection. The push and pop operations are performed only at one end of the stack, which is referred to as the top of the stack. In other words, a stack can be simply defined as last in, first out, or LIFO data structure. The last in first out data structure is a kind of data structure in which the element which was added at the very beginning will be removed from that structure at the end. That means the element which was added at the last, it will be removed at the very beginning, after that the second last, and it will keep on going until it reaches to the very first element which was added in the structure, and it will be removed ultimately from the stack, leaving the stack as empty. So let's see how the architecture looks like. So let me insert some of the element into the stack and let us see what happens. So I tried to push one element of integer data type 23 and it went into the stack and it is sitting at the bottom. Now let me insert one more element. So 4, it is the second element of the stack but it is sitting on top of 23. Now let me insert one more element, that is 55, which is the top element of the stack and it is sitting on top of 4. So if I have to pop out these elements from the stack, I can't pop out 23 or 4 before popping out 55. First I have to pop out 55 from the stack, then 4, then 23. Let's see how pop works. So we are having the same stack and we are trying to pop out 55. So after 55 is popped out, it comes to 4. Then after popping out 4, we can pop out 23 now. And as you can see, after popping out 23, the whole stack is empty. So guys, let's implement stack data structure in code and find out how push and pop functionalities work. I'm using Eclipse IDE with JDK 1.8 for developing this program. So let us create a class and name it as my stack. Here it is. So while creating this stack class, we have to create few class level variables, that is like our the stack size and the stack array and the top element. So here I am creating the variable stack size, which will hold the size of the array, stack array, which will hold the elements of the stack, private int top, which will hold the top element. Now let us create this constructor. It is actually a custom constructor which we are going to create, and where we are going to pass the size of the stack array. Basically, a constructor is used for creating an object of this class, and every class have its own default constructor, but we can create custom constructors also. Let the stack array equal to new int and this size equal to stack size. Here it goes. And top element equal to -1, and this is it. Now let's proceed with the push method. The push method, and we will be passing the parameter of data type integer. Let's give a check over here. If the stack is full, let's throw an exception. uh, let's create another method, stack full. So guys, I'm writing directly this method without I'm calling a method without creating it, because I'm using a powerful IDE. It's Eclipse, which will see now the error it is defining. Error it shows, right? Just click on the error, and we are having the template for the method. Now let's create a method. Inside the method, let's fill the content of it. Top equal to -1. No, that's for the empty check. Is stack full? See, now the error is gone. Let's create a new exception over here, and we will type a message also. Stack is already full. That's it. Now it is throwing an error as we are throwing an exception without declaring in our method signature. So we have to throw it in the method level. Here it is. See, the error is gone now. Let me print some message whenever we are entering some element in our stack. Let it be already plus entry, so it will print the entry in our console. Plus top equal to entry, so it is going to store the entry into the top position. Here we are going with the pop method, and as we did in the push method, we did a check of our array. Similarly, here also we will be doing an empty check. So let us create a method called is stock empty. Now let's create this method. If you put your mouse on the error, it will show why it is throwing an error. And Eclipse is a powerful IDE, so it helps us to create the template of the method also. So top double equal to -1, and we are doing the empty check here. Now let's throw this exception in our method. Inside that, we'll be throwing a new exception with a message. Let the message be stack is empty. Now let me print a message whenever we are trying to pop out any element from our stack. So let it be removed entry and print the entry key. Oh, I have to create an object of that entry first before printing it. So it was my mistake. Let me create that entry of int entry equal to this dot stack array top minus minus. Okay, now I can print this entry. Let's return this entry. So here you can see one more error, as this method is of type void, but I'm trying to return something from a void method. So let's change the return type to int, and we are done with the pop method. So this is how we are going to implement our stack class, custom stack class in our in Java. Now let's use this functionality from our main method. So let's create an object of this class. My stack equal to new my stack, and define the size. Let it be 10. Now let us push some element into the stack. Let my first element be 12. It is asking me to either throw an exception or surround it with catch and try and catch block. So let's push one more. Let's push one more element. Okay, we have successfully inserted 4 elements in our stack. Now let's run this application and check what happens. So as you can see in the console, the elements are printed in sequence. First 12 got inserted, then 2, then 55, then 42. Now let us try to pop one of this element. If we are popping an element, see the 42 Number 42 was removed from our stack. 42 was the last element which was pushed into the stack and it was popped out for the first time. Means in the first time. Let's pop one more element. Now you can see 55 was removed. First 42, after that 55. 55 was the second last element in our stack. So while popping in our first pop method, 42 was eliminated, then after that 55. Now let's try to pop one more element. Now you can see 3 was eliminated. So 3 popped out for the third time. So from this example we can see how the element which was added at the end was popped out when we are trying to pop the element from the stack uh, at the first, and the element which was next to it was popped next to it, and it will continue so on until it reaches to the element which was added at the very beginning, and the element which was added for the first time will be popping out from the stack at the end. We can use stack data structure in various places. Suppose we are having a kind of equation like this, 2 plus 4, inside brackets we are having 4 plus 5. So first we will be storing all these things in stack, and first it will be computing 4 plus 5, and after this brackets, the equation which is there inside the brackets is getting computed, we will be computing it with 2. So, means a 9 first, the result will be 9, after that it will be getting computed with 2. So in this kind of scenarios we can use stack, and there are other implementation also. Suppose like reversing a word. So each character we can store inside the stack, and when we are trying to reverse it out, we will be reversing it, we will be popping one by one element. So the last character which was inserted, it will be popping out at the first, and we can easily reverse our word. And other real-time mechanism is like the undo functionality. Whenever we are typing something in our text editor or something, it is also doing the same functionality. It is putting every character inside a stack, and whenever we are doing control Z, it's undoing it. So in that case it is popping out the last entered character. So this is one more, you can say like this is one more implementation of stack in our real time. So thanks guys, thanks for watching the video, and this is all for stack, and see you later with my next video. Thank you.